Good morning, everyone. Hi, welcome to the bonus stream for the Flexi Week. We're going to talk about problem solving today. I'm Sasha. I'm one of the academics, an education-focused academic at the School of Computer Science and Engineering. And my background is in human-computer interaction, cognitive abilities, so things like problem solving. And I've also spent a lot of time in industry doing software testing, which kind of puts me in good stead to tell you when you're not doing, when you don't have good software. But also I know the common mistakes that people make, and I've also worked as part of teams where I can see the barriers to problem solving and also what issues people might have when they're trying to solve programming problems, and you do have a lot of programming problems. But problem solving is something that we actually do every day. This morning I woke up and I was trying to decide what to have for breakfast. That is a problem that I had to solve, and our problem solving depends on a bunch of factors. I suppose for my breakfast, I thought, how much time do I have? How much effort do I feel like putting into this breakfast? How long do I need to be not hungry for? And so on and so forth. But it is an example of a problem solving ability. You get out of your house, not now, I guess. You don't get out of your house this week, but on a usual day when you're not in a stay-at-home orders or in lockdown, you might get out of your house and you might decide, I'm going to walk to the bus stop or I'm going to catch the bus and the train. And you will base your decisions on a whole bunch of factors. And those are all examples of problem solving. And those are also all factors that you can apply in coding and in programming problem solving as well. And we'll talk about that today. And then we're also going to do some examples and try and solve actual problems. So how exciting. I thought we would start with getting you all warmed up because it is Flex Week. I hope that all of you have been sleeping in and enjoying a little bit of time where you don't have to have your Zoom fatigue happening, and that you don't have to, be anywhere at any time. You can just chill and try and catch up on some sleep and some rest. All right, so let's warm up with some puzzles. That's a good place to start. All examples of problem solving. This was one of my favorite puzzles when I was growing up. I don't know why. There are many variations of it. I've chosen to go with the farmer one. So a farmer has a riverbed beside his farmhouse. On one side of the river is a shop. He's on the other side of the river, his house. He goes to the shop and he buys a fox, a chicken, and a bag of corn. I'm not sure why he buys a fox. There is no logic to this question, so don't try and find logic in it. Then he needs to get back to his house. He gets to the riverbed and he realizes that his boat can only take sort of one item at a time, or one animal at a time, or one item at a time. So he can only take himself and one other thing across. Now, the chicken can't stay together with the bag of corn because the chicken will eat the corn, so they can never be left together alone. The fox can never be left together with the chicken because the fox will eat the chicken. And so this poses a problem of how you can cut them across the river in such a way that no one eats anyone, and hopefully you get all three across the river to your farmhouse. So I'll give you a few minutes to try and solve this problem. There is a link. I found a link where it kind of does it in a bit of an animation way. So you can, if you follow that link, you can actually try and see whether, kind of play in a game sort of setting as well. So we'll give it 2 minutes and then we will go through what you might have done to solve it. Has anyone seen this problem before? I'm sure you have as you have sort of grown up. Has anyone seen this problem before? I'm sure you have. That was me logging on another device. Sorry, I'm getting used to this. So you might have heard me talking on another device with the lag. All right, well, let's have a look at what we can do to solve this problem. Okay. Let's say we have the riverbed happening, and the riverbed is in the middle. Okay, then on this side we have, that's a riverbed. On this side we have the farmer. And let's call the farmer, oh, the writing's getting bad, sorry. The farmer, then we have a fox. We have the chook. And we have the corn. Okay, who do you think will go across the road first? What does everyone think? Okay, chicken first. All right, so that means the farmer and the chicken go across first. Farmer and chicken go across first. The farmer will leave the chicken here, so the chicken has now moved into this side of the river, and we now have the fox and the corn left on the opposite side. Okay, the farmer then returns across, and he can now choose whether he's going to take the fox or the corn. Which one will you take? Fox. Okay, so then the farmer goes across with the fox. He now has the fox. And what will he do now? If he goes across now on his own, if he goes back on his own, the fox will eat the chicken. Excellent. So someone say, take the chicken back as well. Okay, so the farmer's now going to take the chicken back with him and bring the chicken back to this side. So the chicken has reinstated back on this side. The fox has now gone to the other side. So now on the right side, you've got the farmer, the chicken, and the corn. And what will the farmer do now? Okay, take the corn then. So the farmer and the corn will move across. So now on this side we've got the corn and the fox, and on this side is the chicken. And then the farmer will obviously go back and take the chicken across, and then you will have all three on the other side. Well done. So this is a puzzle that you usually give to children, and it's actually demonstrating one of the common ways to solve a problem. It's called a means-ends analysis. And what that does is all that we have is really what it should look like at the end, and we take guessing steps to solve it. We only look one step ahead at each time. We don't have any sort of method to go by. We don't really learn anything when we are solving this puzzle. We're not actually learning anything from it. All we're doing is we know what the end result is, and we're going to get there somehow. And I would imagine that a lot of you, when you were at school, and you used to have your maths textbooks. Another example of that is, the answers in the back of the textbook. You would always look in the back of the textbook, and then you kind of try to get to that answer in a series of steps. You're just kind of trying to guess how you would do it to get to the answer that's in the textbook. That is another way. That is also called the means-ends analysis. So you have what you want to finish up with. You have what you want to start with. So you have your input and your output. You're not really sure what goes in the middle. There are no particular series of steps, and you don't learn anything when you solve these types of problems. So if you do not look at this problem for another 3-4 months, you probably will not remember how to do it. Okay, let's look at another one. Okay, next one. My daughter is twice as old as my son and half as old as I am. In 22 years, my son will be half my age. How old is my daughter? Okay, so if you try and solve it and you tell me what you think you would do or what the answer is, how old do you think the daughter is? And then also how you would go about solving it. I hope this one also doesn't bring everyone back to high school. I remember there was a whole unit of a lot of these types of problems. So I'm sorry if it's bringing you back little flashbacks. So has anyone solved it? How old do you think the daughter is? Any ideas? How old is this daughter? All right, well, what strategy have you adopted to solve it? How do you think you're going to do it? Okay, someone says 22. Any other Any other ideas? Or answers, not ideas. I guess these are not ideas. You actually are working out an answer. How did you go about solving it? What did you use? What strategy? Did you use guessing, trial and error? Did you use some algebra and actually wrote some equations out? Then did you make them simultaneous equations? How did you do it? What strategy did you use? There are obviously a number of ways to solve this problem. William, you took just a guess. Okay, so there is a number of ways to solve it. You can do trial and error. Obviously, trial and error will probably get you an answer. It might not be a super efficient way to do it. You can also use some algebra. You can do some nice simultaneous equations. And if my pen would work a lot better, I would write them out. 22 was close, but that's the age of the son. 44 is the age of the daughter. And I'm 88. Unfortunately, I've gotten quite old whilst giving this lecture. Okay, what about this one? Let's try this one. 3 boxes contain 2 coins each. One contains 2 5-cent coins, one contains 2 10-cent coins, and one contains a 5-cent coin and a 10-cent coin. All 3 boxes are mislabeled. Each contains the label of one of the other 2 boxes. If you are permitted to take out only 1 coin at a time, how many must you take out in order to be able to label all 3 boxes correctly? So this is another fun one. The last one, you relied on your prior knowledge potentially, knowledge that you might have had from school, knowledge of mathematics, knowledge of algebra. So you were able to solve it like this. This one is not as easy to solve with prior knowledge. This one is really, you have to use some logic and you have to be able to understand the problem clearly. So let's see if anyone can do this one. So can you tell me how many coins you'll take out, and out of which box will you take it out then? How will you solve it? So another method that you use in problem solving is to draw diagrams. And I'm very fond of diagrams. I think once you draw a diagram and you visualize the problem, it becomes a lot easier to solve. So you've got 3 boxes, and each of the 3 boxes has a different combination of coins. So one of those has 2 5-cent coins. One of them has 2 10-cent coins. It's taking a lot of effort to do this. And a 5-cent and a 10-cent coin. And there is also 3 labels. where will you take out, which coins will you take out, how do you reckon, what do you reckon you would do? So there's 3 labels. One is obviously going to be called 5-cent coins. One might be called 10-cent. And one is a 5-cent and 10-cent label. So has anyone got any ideas? It's too much brain power for an early morning on a Tuesday. Okay, 2 coins, one from any 2 boxes. Okay, can anyone do better than 2 coins? That's an excellent guess, and that will definitely get you the result that you want. But can we do better? Can we do it in a 1 coin reveal? So the important thing here, and this is the biggest problem solving strategy, is understanding the problem and making sure that you take out any redundant information from the problem and you keep only things that matter to you. Ben, just open the boxes and look inside. This wasn't listed as a constraint. That is an excellent idea, and actually comes in nicely into one of the things I talk about, is that one of the barriers to problem solving is that we build up constraints against a problem. So most of you would have assumed you can't do that. You can't open the boxes because, how would you? That just feels like it should be a constraint. But that constraint was never written in the problem. So these make-believe constraints are often one of the barriers to good problem solving. So that's definitely an excellent way to do it, because that certainly wasn't given as a constraint. So you can take one from the mixed box. And the key here is that all 3 boxes are mislabeled. Okay, so this box is going to have not a 5-cent and 10-cent label. It's going to have either a 10-cent or it's going to have a 5-cent label. So if you take 1 coin from the mixed box and you know that all 3 boxes are mislabeled, then the box either contains 2 10-cent coins or 2 5-cent coins. And then you can put the correct label on that box after inspecting one of the coins. And then all you do is just switch the other 2 labels. Because, again, you know that all 3 boxes are mislabeled. So a few things here in this question. One is to understand the problem, to read it, to make sure that you understand what the important information is. 2, to not build up constraints. And to try and not put in constraints that are not really there. So just open up the boxes and have a look. No one's told you not to do that, and you're able to solve it quite easily then. Okay, let's do one more. Okay, an egg salesman was asked how many eggs he had sold that day. He replied, "My first customer said, 'I'll buy half your eggs and half an egg more.' My second and third said the same thing. When I had filled all 3 orders, I was sold out and I had not had to break a single egg all day." So how many eggs did he sell that day? So pop your number in the chat if you've got a number for how many eggs that salesman sold. Seems like a limiting problem. Ah, yes, someone's got it, 7. How did you work that out, that it's 7 eggs? All of them, yes. How did you get 7? Trial and error. Okay, that's another strategy for problem solving, trial and error. It's not an efficient strategy, but it is a strategy nonetheless. And you know it's not efficient because when you sit in exams and you try and do trial and error, the time pressure really gets to you because you don't have time to do trial and error. One way to solve this problem, and it's solved a lot easier if you start from the last customer and work backwards towards the first customer. So because they're all getting sort of half an egg more, you know that there's going to be odd numbers. So if you start with, 1, the last one gets 1, then what does the second one get? 2, and then the last one will get that, again. So if you can work backwards as well, which is not, it's not a natural way for us to work, to start from the last part and get to the first part, but that is definitely another strategy as well. So no one puts in a constraint that you have to start at the start and go to the end. Sometimes you might start at the end and go back to the start. Just like no one really constrains how you read books. Some people do go to the end of the book and read that first because they want to see how the problem was solved in the book. So you already kind of incorporated a lot of strategies to solve these problems. A lot of these kinds of puzzles, they lend themselves to the trial and error or to means ends analysis. So what it means is that you don't actually learn much from solving these problems, except for, perhaps they are enjoyable, but you do get to use some logic in order to solve them, and you can hone in your skills in understanding problems and understanding what it is that you need to do and then working out how you would approach it. So problem solving is, everyone thinks, you're either good at problem solving or you're not good at problem solving. That's not really the case. Solving problems is really, it's a skill. It's a practical art. It's the same as swimming. It's the same as skiing, the same as playing the piano, in that you can only get better at it by practice, and by watching other people do it and then, learning from how they're doing it. So if you want to learn how to swim, you have to go in the water and actually, learn how to swim. And if you want to be a problem solver, you have to actually solve problems. So in this course that you're doing, you're programming. And so you can't just expect to be good at programming without learning how to solve the problems first. So it's one thing to understand the syntax of the language that you're learning. It's one thing to be able to do a great if statement. It's one thing to be able to do a great while loop. But if you do not know how to put those together in order to actually solve a problem that you're given, knowing the syntax very well is not going to be helpful to you. You need to be able to actually solve the problem. You need to be able to know how to approach that problem. You need to be able to break down the problem and to actually solve it. There are ways that you can improve how you think about problems. There are strategies that you can adopt in solving problems. But most importantly, I hate saying it, but practice does make perfect. And this is especially true of programming. You get to learn different strategies for solving different types of problems by doing it. And what you do in this sense is that you build up your expertise. So problem solving is an essential skill in coding because, you can't, every sort of coding question you get is really an exercise in problem solving. It's not, you have to be able to apply logic, or you have to be able to apply your prior knowledge. You have to be able to apply certain strategies in order to solve these problems. One of the biggest thing is you guys are starting out, as a novice, but hopefully throughout this course you are going to progress. You will perhaps not get to the master status, which is, the aim. but you will start to get close, you will start to move across and get close to it. Now, when you start out as a novice and when you move to a master, there's very different ways in which we solve problems as novices and experts. And the only way to build expertise and the only way to move through the different stages of problem solving is to actually solve problems. So again, practice, 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 do lots and lots of problems. So there's 4 different ways in which novices and experts differ in the way they solve problems. And, as a novice, you might want to adopt some of these strategies to try and build your expertise as well. So one of those ways is in the way that we represent problems. As a novice, you see problems in isolated pieces, which means that you kind of see them as this section and then this section together, and you can't actually join it together cognitively because you don't see the relationships. But as you begin to build expertise, an expert, when they solve a problem, they will search for context and relationships and problems, and they will be able to link up the problem in a way where every part of it fits in together and makes sense how things work together. What it means is they can also see what problems might arise when they're solving the problem, and they can foresee perhaps what else they need to do in order to solve the problem efficiently. There is also a difference in problem solving efficiency. A novice will solve problems slowly. They will focus on the mechanics. So often when you're a novice and you approach a problem, especially in coding, you'll start straight away, you'll head off and you'll start writing an if statement or a while loop, and you are just going to kind of focus on the mechanics of solving that problem as opposed to understanding what the problem is. When you become an expert, you solve problems a lot quicker. And you possess knowledge, it's called schemas. You possess knowledge, cognitive knowledge in your brain that is automatic. So your syntax knowledge becomes so much more automatic that you do not need to think about that as much. So you are more focused on solving the problem. Whereas when you're a novice, you're not only trying to solve the problem, but you're also trying to put the syntax together as well. And when you're trying to do both of those things, you can become cognitively overwhelmed. It can become a little bit too much. And that's when you start to sort of blank and just not really know what you're doing. So another way is the way you plan for problem solving, and this is something that you can start to improve now. Novices don't really do a lot of planning. They just kind of jump into it and start to problem solve. So if you have been in the lab in the last 5 weeks and you read the question and you got so excited you went straight to gedit and you started to write your code, that is what I mean. You haven't planned your solution out. And so a novice will quickly adopt and they will quickly try solutions, whereas an expert will plan before they write any code, especially in unfamiliar problems. So you will sit down and you will write out what it is that you're doing. You will think about what is happening, and then you will actually approach the coding problem. So often with coding, don't jump into the coding first. Actually sit down and think about the problem, and then we start to build the code into that. And we're going to look at how to do that in a few more slides as well. And the last difference is in the way we monitor problem solving. So the way we actually monitor our solution. In that, novices, because you have limited knowledge and limited understanding still, you will often persevere with unproductive strategies. So even when you're on the wrong path, you might be going down that wrong path for an hour before you realize you're doing something wrong, and this is probably not going to work. And this is part of the fact that you don't yet have enough prior knowledge and prior understanding of both the language and the problem-solving ability that you don't see when you're running into errors. Whereas when you become more expert, you will see straight away that you're going down the wrong path and you need to abandon it straight away. So you're able to abandon inefficient strategies a lot faster than when you're a novice. And it comes from the fact that as an expert, as you build that understanding and you build your prior knowledge, you're able to see past what you're writing in terms of code or past your step 2 of problem solving. You can see into step 4 and 5 and what effects your step will have onto the further steps. So that's really something that also helps you solve problems. And the only way to build that expertise is to solve problems. So that's the only way to get better. There's no way you can get better without it. All right, so some strategies for problem solving, and these are really should be applied when you're solving problems. This is a way that you can, build expertise, and this is the way that you can also dissect a problem and ensure that you can solve it more efficiently. First of all, and most importantly, you should understand the problem. You might have to read it once, twice, 3 times, and after that, you should try and define the problem yourself. So can you paraphrase the problem in a way that makes sense? Does it make sense to you? Does it make sense? The best way to test it is to paraphrase it to someone else, to a friend. And often at an industry, we don't work as lone wolves. We work as in teams. And so when we have a brief, we will come together and we will talk about the problem. We will try and understand the problem together. We will paraphrase the problems together. We will decide what the problem is within the constraints of requirements of the project. But you are not, it's not relying on one person understanding the problem. You're always trying to see if your understanding is the same as someone else's understanding, so everyone's on the same page. So be sure that you understand the problem and what's going on. What are the inputs? What are the outputs? Are there any constraints? Are there constraints that you've made up, or are there constraints that are actually there for you? So make sure that you can restate the problem in your own words and explain it to someone else. That's the best way to understand whether or not you understand the problem. Start with what you know, and we will talk a little bit more about that when we actually do the problem. Reduce the problem. I cannot stress that enough. Usually you will get a problem and it seems very overwhelming at start, and that is the case in coding. You often read some of these. I think some of the code breaking ones that you did with characters and strings in particular, often the first read of it, it just feels like way too much. Like, what on earth is this problem talking about? What does it want? And this is where it's important to break it up into much smaller steps until you get to a step that you know how to do. And it might be something as simple as using one scanf, okay? It might be something as simple as using a printf. But what it means is that you're breaking up your problems into a series of smaller and smaller steps to the point where you can do something and you can start building up some confidence as well. Okay, I've achieved doing this one little step. Can I do that in a bigger context? And then again in a bigger context, and then again in a bigger context. So we reduce our problem down to the simplest problem possible until we know how to do something, and then we try and attempt it. The next one is to look for analogies, and this is where you build up your expertise of different problem-solving abilities. If you look for analogies, you usually have done similar problems in the past, and you might be able to bring something into your problem, a problem that is similar but not the same, but would have used the same sort of strategy to problem solve. Worked example, I know that, sometimes you don't know how to do something, you might Google it, and you'll see an example of someone doing it. Please don't just copy it across blindly. Not only is that plagiarism, but it doesn't teach you anything. It doesn't make you better at coding. Feel free to look at that example, to break it down and to understand what that example is doing, and then try and recreate that example yourself without looking, because that is going to be something that will actually teach you something, and that will leave something, with you. Sorry, you can hear my dog shaking off her sleep. Okay, experiment, and that's part of that whole trial and error thing. Sometimes you might have a statement that, is just slightly off, or something is, just a little bit not quite right. And experiment, try different things. Sometimes do I need to have a less than an equal, or do I need to have just a less than it might just be a case of fine-tuning things and experimenting with where you're going to get. And also, don't get frustrated because any time that you make an error, that's actually an excellent strategy for learning. That's what helps you to build expertise. Once you see an error, once you see a compile error, or once you see a certain type of error, or where perhaps it's compiled but it hasn't given you the right output, but you can see what you've done wrong, you now know if you get something like that again, you know exactly where to look for it, you know exactly how to solve it. So every error is actually a good thing, because what it does is it helps you build expertise and it helps you understand what is going on a lot better. So you get a more intimate look at code, you get a more intimate understanding of problem solving, you get a more intimate understanding of the syntax, and it allows you to really put everything together and not to make those errors in the future, or even if you make those errors in the future, to solve them very quickly. Okay, so there are some barriers to problem solving. It's not, problem solving is simple, but it's not really that simple. It's a skill on itself. One of those problems is something called a mental set. And a mental set is a tendency to only see solutions that have worked in the past. And this really stops you from being able to come up with different or more efficient solutions. So it can really impede the problem solving process. Because of the mental set, you will not be able to see a more simple solution. And that's, if you've solved a coding solution in one way and it's always worked, you will always continue to solve the problem in that way. And you will not try and look for better ways to solve the problems, or perhaps for more efficient ways to solve the problems. And that's something called a mental set. The next thing is functional fixedness, which means that once you define an object as only having one function, you cannot look past that function. So a physical example is like scissors. You are so used to using scissors for cutting things that you cannot think of scissors as anything else. You're not going to use scissors as a weight. You're not going to use them as anything else except for to cut things. And that's an example of functional fixedness. So we become so fixated on what that object should be doing that we cannot look past its functionality in that way. We sort of become obsessed with what with what it's meant to do. And this is in coding. This is you become, I suppose, so used to using. I don't know if you guys have learned post increment and pre increment yet, or the difference between them. But you often become so used to using one or the other, you stop. You don't even think about what you're going to do. Its function is so fixated in your mind, you cannot go past it. So again, it will stop you from solving a problem, and it will stop you from being efficient in solving your problem. Now, as a novice, you actually have the upper hand, because as a novice, you don't yet have functional fixedness, and you don't yet have very solid mental sets. So in fact, you guys do not have those two particular barriers to problem solving. You are still, immune to those issues. So that means that you can think about things in a really different way, in a really interesting way. It might not work all the time. It might not work 90% of the time, but you should try all the different combinations and learn from them as well. So the third way is unnecessary constraints, and that's something that we saw in the coin problem. Constraints that are not part of the problem. They are things when we kind of subconsciously place boundaries on the task, and it really strains us to be able to innovate or to think clearly in a different way, because again, we're fixated in what the perhaps constraints are, and we cannot think of outside solutions where those constraints do not exist. So again, it's really important to not put in constraints, or to try and only use the constraints that you are given to a problem, as opposed to putting them in yourself. And the redundancy effect. Often the questions that we get asked, or the problems that we get given, they will have information in them that is redundant. That means it's unrelated, it's not important to our specific problem, but it is there. And within the specific context of the problem, that irrelevant information, it has no purpose in helping us solve that problem. What it's actually doing is it forms a barrier. Cognitively, it's demanding your attention, because you still have to see it, but it's not helping you to solve the problems. So it is a detrimental thing to problem solving. And I think in school you were often told, highlight what's important. And that's kind of the case here, but I always draw, and this is why I always go to a diagram. A diagram is one way that you can remove redundant information, because you can draw out what is necessary and you can leave the rest behind, kind of thing. And that means that you are only visualizing the problem with parts, with the cogs that are important to that problem. So you're able to picture the problem better and in a more efficient way. So irrelevant information makes solving relatively simple problems a lot harder. Okay, so the next parts are all going to be about coding, problem solving and code. I'm not sure if we take a 5-minute break just to kind of get ready to code. So maybe let's take a few minutes break and then we will come back ready to code after those few minutes. right, let's do it. Some coding time. Okay, let's start with some simple problems, and what we'll do is over the next hour we'll build up the difficulty of them so that you can see the strategy of reducing the problem right down, and we're going to even reduce the simple problems right down. So write a program that uses no more than 2 output statements to print a half of a perfect square with the hash characters like so. So let's say the input is, the size is 4, so you want to print a 4 by 4, but you want to cut it across so it's a half square. So let's have a think about how we would be approaching this problem. If you were to see this problem, and you guys have seen types like this, because I think in week 1 and week 2 you did do some printing out with characters, I think week 2. How did you approach this problem, and how would you approach this problem with the experience that you had in week 2? So what approach would you take? What steps would you do? Would you jump into programming straight away? Would you open up gedit and be like, yes, let's do it? I hope not. I hope first you sit down and think about it. Okay, so what are some things that we need to consider out of this problem? The first thing is we need to understand the problem. So the problem has said that we only have 2 output statements, which means that I can't just, write printf and print out 4 hashes, printf, print out 3 hashes, printf, print out 2 hashes. Basically, it's prohibiting me from doing that. It's prohibiting me from doing a very manual solution to this problem, a very basic solution that would, potentially pass some tests, but it wouldn't actually be an efficient solution to a problem. What are the inputs and the outputs? So what are the inputs for us in this problem? The inputs are, what is the size of this square? So what is the side length that I'm adopting? And the outputs is the half the square printed out in hashes. Let's try and reduce the problem to make it easier to solve. Okay, so that half a triangle is, it's not super hard, but let's reduce it to make it even simpler. What about producing a square of given size n? Okay, let's say your n is 3, side length 3, so now you would be producing 3 by 3, and you're producing a square of size 3 by 3. Okay, you can do that, potentially, but let's say you don't know how to do that. You don't know how to produce a square of given size n. So you want to reduce the problem even further until there is a step that you do indeed know how to do. So let's say you do not know how to produce a square and you want to reduce it further. Do you know how to produce one line? So can you produce one line? I'm not sure. What happens if you can't produce one line? Could you produce just one hash? And that's something that you could do, because you would just printf and then you would printf a hash. So you could reduce it right down to the very, very, I keep wanting to say, just simplify that fraction, kind of like this, bring it down to its simplest form until there is something that you can do. But printing out one hash is the simplest way to do it. But then what about printing out 3 of them? Can you do that? How would you do that? You do have enough information to be able to do that. So what would you do in order to do that? Okay, so for one row, we know what to do. We want to know what are our inputs. We want to know what size it is, don't we? We want to know what is the side length that we need. How do we do that? We know that there is something that we can use. We can use scanf to take in to understand what the size is that we need. And if we're printing out one row, then we also need to print out n lots of that hash. Yeah. So if we want to print n lots of that hash, potentially we could use a while loop to do that, because that is involving repetition, and for that sort of repetition from 0 to n, we would print out that number of hashes. Okay, and then what else would you do? You would probably print a new line in, because, depending on your problem, right? And printing a new line, I guess, prepares us to print out the next row, where you would perhaps have, your square going, so your 3 by 3 square. So it's quite a trivial solution to do for one, but what about to do it for n number of rows? So now we want to really expand it for n number of rows. So we've got one row where we're printing out 3 hashes, and now we want to go down again. So perhaps how would I do that? To go through the number of rows, I might use another while loop, and each time I would put in the code to print out one row inside that big while loop that counts down the rows for me. So in this case, I would have, I'll take in the side here that will give me what the n is. Then I would print out n lots using a while loop. So perhaps I would start some sort of counter, and I will go until that counter is equal to n, or whilst it's less than n. And then I will print out the hash. And then I will need to go through the number of rows. So again, I will have I will have a counter, and I will count up through the rows with another while loop. I need a better tablet, as everyone can see. I'm trying to write on the screen using a touchpad. That's why it looks absolutely horrible. Okay, so if we can print out a square, which we can, potentially, we can see the logic in printing out the square. We've reduced it to that. What about a half triangle? So what the problem was. So let's see if we can look for a pattern. If the size n of the half square is 4, then what it looks like is we print out 4 in the 4th row, we print out 3 in the 3rd row, we print out 2 in the 2nd row, and we print out 1 in the last row. So can we see some sort of pattern emerging? Obviously, if my size that I've taken in, so if I've scanf'd in an n, and that size, so my first row, I'll print out n. What will I print on the next one down when I have to print out 3? And if I'm in my while loop, I'll have a counter, won't I? Let's say that counter is cold row. Yep, so well done, n minus 1. And what will it be on the next one down? Yep, well done, so n minus row. So if I'm inside this row, I'm printing out really n minus row. Okay, what about in this one? Am I printing out n minus row? If I print out n minus row here, what will I get? If my row is equal to this. Yeah. So that's right. So row really has to be a counter. So where row will start from, let's say, 0. And if row starts from 0, then this will be n minus row, which is n minus 0. I might increase my row to 1, and then I have n minus row, and then I have n minus row, and I have n minus row. So that will work perfectly then. So we've used a few strategies here. We broke down the problem. Well, hopefully we understood it first. We broke it down, and then we experimented to find the pattern that will perhaps give us the formula for actually doing the code. So let's see how we would do our code. Okay, so print out a half square. All right, so, well, of course, we just start out with the usual. Okay, and then we broke down the problem into a number of steps. So let's write down what steps we took to break down the problem. Okay, so we decided that the problem can be broken down into a series of steps. Take in what the size is of the square. Okay, and we've decided that we can use a scanf to do it. So then we want to do, we can produce one row of hash. And we said we might do that with a while loop. And then we will expand it into n rows of hash. And we said that we do that with another while loop. And then in between there, what's really important as well is that you do perhaps some error checking as well. And we'll talk about that. I guess that's not really, you can talk about that, or we can talk about that later. But always you should check for errors straight away. To make efficient code, you should be checking that something has been scanned in, or that something is coming out, and that you've scanned in what you need to scan in, that it's not just rubbish as well. So that's something that you should be doing as just part of the course, hopefully on autopilot now, but perhaps not. So let's start writing. Let's see what we can do here. Okay. All right, so we want to take in the size. So let's do our variable size of type int, and we're going to ask the user what size they would like. Okay, who wants to tell me how I might want to check for an error? Does anyone know how I might check for an error when I use scanf? Yeah, well done. So check to see if it returns the value of 1. And if it doesn't, then I will perhaps do an error. So there's a number of ways to do that. We can just do this for now. So if scanf is not equal to 1, then we might have some sort of error. Spelling. Struggling with spelling. Okay, and then I'm going to exit out because obviously there's not much I can do unless I ask someone again. So that is another possibility, that I might ask someone again to enter in the scanf output. Okay, so we've taken in what we want to do. So now we can do print out one row, produce one row of hashtags. Okay, so I want to have some sort of counter of those hashes. So let's do a hash, let's do a counter. So whilst it's less than size, I'm going to print out the hash. And then what else do I need? I need to increase my counter. And what that will do is that will give me, if say the size of it is 4, that will print out 4 in a row. So what that should do, so let's say counter is 0 here, 0 is less than 4. It will print out 4 of this. So it should finish up by printing out that at the end of this while loop. Okay, so that's one row. What happens now? How do I expand it into n rows now? Because I want to repeat, what I want to do is I want to repeat this, and that will give me a square, and then we can talk about how to repeat it for, doing a half triangle. So I want to repeat this, let's say, for each one. Yep, so another while. So I will encase it in another while loop. Excellent. So whilst, and I'm going to need another counter. And you can always, refactor your code as well afterwards. Okay, so what will this produce? Will this produce the right thing? Okay, almost the right thing. And that's part of experimentation. So I'm missing something. Yep, so for one, counter doesn't get reset. Yep. Well done. So my counter is going to be, well done. Look at that, everyone is on top of it. So what should I do to reset the counter? Where should I put it? And no new line, that's right. So where do you reckon I should put the new line? Do you think I should put it before this row plus plus, after the row plus plus? Doesn't matter. Okay, so we've got a new line and we want to reset the counter. Where would you reset the counter? Excellent, well done. So move the counter in so that it resets each time that we enter a new while loop. So we enter a new row, we reset the counter back to 0 because we wanted to go back to the front. So once it finishes over here, for the next row, we wanted to move back to the front. So kind of think of it as a typewriter going back and hopefully getting reset. Okay, so now if we print out, we've got a perfect square, which is fantastic. So we've solved it to the stage before we get a half triangle. And if we want to do a half triangle, then we kind of also got the formula for it, where we said that it's going to be equal to n minus the counter of whatever row is going on. So then where would I insert that, do you think? On which line? So my rows would stay the same. But what would I change? What would I change? So would my counter always be reset to 0, or perhaps it would be reset to something else? I forgot what I asked. Someone replied 27. That's not even the magic number. Yeah, size minus row. Okay, so my counter shouldn't really be 0. My counter should be reducing down. So size was n, and not row. So let's just see what does this do? Oh, I hate it when it does that, sorry. Okay, so and this is part of the experimentation part, okay? So don't be scared to make mistakes, okay? So if you have, so that's probably because I haven't saved it, yes. So don't be scared, mistakes are good. It's when you can see what's actually happening, and that means that you can fix it, okay? So now we get a nothing, and then a 1, and then 2, instead of going the opposite way. So the problem is with our counter. Row is equal to 0, and size is equal to n. So when I make the counter equal the first one, it's going to be 4 minus 0. So what do you reckon? How could I solve it? So what do you reckon? What's happening? Why is it printing out this gibberish? Well, not gibberish. I'm counting down the wrong way, aren't I? I'm going 0, 1, 2, and I need to be going 3, 2, 1. So if I'm counting down the wrong way, then what do you reckon is happening? The one way to do it is to sit down and just to have a look what output it's giving us. So on the first round, this is going to say that counter is equal to size minus row. Size is equal to 3, row is equal to 0. So it's going to be equal to 3. Then on this part, it's going to be counter less than size. So counter is less than size, isn't it? So counter is less than size. I'm going to print out, so it's only going to print out, I'm going to get a bit of an issue here, aren't I? Because I'm not starting with the highest number. So what do we reckon we could do? And because then here I will increase this counter, which means I'll go up 1. So perhaps we need to change the condition of our second while loop. What does everyone reckon? Because I want to be printing out 4 hashes here. So I want to print, 3, 4. What was the size that I gave? 4. You can do that, absolutely. You can keep the counter equal to 0, and you can change the while condition. So there's always more than one way to solve a problem. Yep, we can. Okay, so let's do that. Okay, so you reckon now it's going to magically print out what we wanted to print out. Okay, so the other way to do it was obviously to change the counter, and then you change your while condition to be going down to 0, so decrementing, not incrementing. So always there's more than one way to solve the problem. It doesn't mean that one way is more right than another. You will notice that as you continue to solve problems, this is where your mental sets come in that you will become used to solving it in one particular way, and it's hard to look past another. So the way I build my while loops, sometimes it makes it hard to look at it in another way. And so that's one of the barriers to solving a problem, as we've talked about. So important to think of different ways that you can potentially solve the same problem. All right, if you take it a step further, what happens? You want to write a program that has no more than 2 output statements to print a sideways triangle of hash characters as well. So what we can see is really this part here we've just done, okay? We've just written the code for it. We are more than able to do it. So somehow we need to be able to address this situation at the top here. And one part of it is, if you look at this, the middle is the number that you've scanned in, and then you've got 2 reflections, one on top and one on the bottom. So this is going to be one part of it. This is the n, that's the size, and this is going to be the other triangle, except that they're reflected. So one is going 1, 2, 3, and the other one is going 3, 2, 1, because obviously we print from top to bottom. So increasing the complexity of this problem. So again, only 2 output statements allowed as a maximum, and we've just said that this problem is very similar to the one we've just done before, but it's expanding on it a little bit. So let's reduce the problem again, back down to 1 line of hashes, which we can do. You can reduce it further to just 1 hash, which we can do as well. And we've talked about it. It makes a very trivial solution. We've just done it. We can expand it for n rows. And we can do a while loop each time with code for 1 row. We've just done it. But now what about doing a half diamond pattern? Okay, so we've seen the bottom half of that half square in the question, so we're familiar with that structure. But let's see if we can look for a pattern to do the top and the bottom. Okay, so let's have a look. So what do we have here? And remember, we had the pattern for here was n, and this was, so we have to print out 3, we have to print out 1, we have to print out 2, we have to print out 3, we have to print out 4, back down to 3, 2, and 1. Okay, has anyone got any ideas of what we can try for our algebraic pattern? So what can we try for the formula that will give us some of the rows? We've done this way, where we said it's going to be n minus counter, if counter is but will it be right up here? So what could be some potential patterns that you could find now? Okay, so we're saying n over here. So if I print out n, that will give me 4 stars. So that's, I need to print out 1 star in row 7. Or you could do the rows the other way as well. I'm not sure why I did them from top down. So what do we think could be the way forward here? So n minus counter on top half, just n on the bottom half. So if we do n minus counter, and what would counter be in our case? So if counter starts at 0, then this will be n minus 0. So this will be 4. So we'll print out 4 hashes. I only need to print out 1. So that might not work. So what could be something else to try? Starting the counter at n is greater than 4. How will you know what to start the counter at? You're definitely heading towards one solution, but how will you know what to start the counter at? If statements. So think about it, you're specifying, if you were to approach it in that way to solve it, you have, let's say you've specified that your diamond pattern will have 4 as the middle row. So let's say you've got size 4, and there are 1, 2, 3, 4, 5, 6, 7 rows altogether. So how could you do that? So size divided by 2. If you have size divided by 2, then you would have 4 divided by 2, which is 2. So what will that give you? Where would you go with 2? Not nowhere much. So that could be, we might abandon divided by 2. So the way you want to do is to do 2 if statements. One that considers where you are at the top, one that considers where you are at the bottom. Is that right? So that is definitely one solution. Is there a more efficient solution? Is there just one formula that you can see that will encompass all of these? And there is one there. I'm bringing you back to your high school maths when you had to look for algebra patterns, which is something that you do have to do a lot in problem solving, coding problems as well. So definitely you can solve it with 2 if statements, one that's considering that you're at the top, one that's considering you're at the bottom. That is definitely one way that you can solve this problem. Let's see if we can do it more efficiently with just one while statement and have the formula in there that accounts for it. Can anyone see it? Can anyone see the formula that could potentially... Okay, if here I have n minus row, sorry, n minus counter, okay? If I have n minus counter, what that will give me is 4, won't it? I want to print out just 1 in that row. So what could I do to do that? First of all, how many rows do I have? So I'm going to keep going for longer than just I to row, aren't I? I'm going to keep going for double that. So my counter for my rows is going to be 2 times the size, because I need to print out over really 7 rows here. And if I do n minus counter here, that will give me 4 minus 0, which will give me 4, and I need to print out 1. So how can I counteract that? Can anyone see a formula? It might use an absolute value in it. Okay, so let's look at it in a different way. Okay, so in row 1, I print out 1. In row 2, I print out 2. In row 3, I print out 3. In row 4, I print out 4. In row 5, I print out 3. In row 6, I print out 2. In row 7, I print out 1. So if my size is n, start with the middle one. It's always the easiest one to do. Okay, what if I say, what if instead of the counter here, I use my row number? Can I just say, can anyone see any solution to this sort of table? Please feel free to say no. Okay, so right now we're printing a half a triangle. What happens if we have a double size? Okay, thank you, Salmon. You can't, that makes it much easier. So let's say we need to print out eight lots, don't we? So we need to print out the top part of it as well. So I'm going to have double the size because I'm going to be printing out from row 7, well, for a size of 4, from row 7 down to row 1. So what happens if I'm just going to compile it and run it? What's it going to print for me if I haven't modified anything? It's just going to print out the normal triangle, isn't it? Because our counter is set to 0 and we're not really changing our formula here. So the formula is wrong because I now want to start with 1 at the top, go down to 3, go down to 2, then 3, and then go to the number and then go back down again. So I want to turn it around now. I want to start with the lowest number. So what if I have this as my condition now? So I have size minus the absolute value of size minus row. Okay, so it's going to print out a half triangle, but it's going to be printing out a space there as well. But the formula is working, and the reason for that is because it's taking into account where I am. So what it's doing is I've got n minus the row. So if my row is 7, 4 minus 7 is 3. So that means if I do my n minus 3, so my 4 minus 3, I'll get the 1. So I'm counting with help using this row and using the absolute value because it's going to help me out with the 3s and to go back upwards again as well. So that's one way to solve it, is to look for these algebraic patterns in it. The other way was obviously to do it with 2 if statements, which someone had already suggested. And let's try a different question. Okay, I think I've fogged you all up with the algebraic stuff. Okay, let's do this one. The Luhn formula is widely used for validating identification numbers. Using the original number, double the value of every other digit. Then add the values of the individual digits together. And if a doubled value now has 2 digits, then add those digits individually. The identification number is valid if the sum is divisible by 10. Write a program that takes in an identification number of any length and determines whether the number is valid based on Luhn's formula. The program should process each character before reading the next one. Okay, so there's a whole bunch of moving parts to this problem. There is a lot happening. And first of all, you really need to understand what on earth this problem is talking about. And what it's saying is, let's say you have an identification number 1, 7, 6, 2, 4, and 8. What you're doing when you're doing this is you're taking every other digit, so every second digit, and you're doubling it, okay? So 7 doubled is 14. Then 2 doubled is 4. And 8 doubled is 16. So you're doubling every second digit. And then you're going to add up all the different integers. So that has 1. This one has 1 and 4. The digit 6. Then this one is 4. This one is 4 again. And this one is 1 and 6. And then you're adding up all of these digits together. So you get 1 plus 1 plus 4 plus 6 plus 4 plus 4 plus 1 and plus 6. Okay? So this gives you 27. And then you check, is 27 divisible by 10? divisible by 10, then it's valid. And if it's not divisible by 10, then it's invalid. Okay? So that's really what that problem is asking you to do. So you had to take this problem and you had to take out all the things that matter in it. Double the value of every other digit, add the values of the individual digits together. If the sum is divisible by 10, then it's valid. Otherwise, it's not. So you need to think about the inputs as well. You need to be able to take in an identification number of any length. So you're not told how many numbers there are going to be in any given number that you're given, and you need to read them one digit at a time and process them, as needed. Okay, so let's reduce the problem. We need to know what to multiply by 2. Okay, so we need to know that it's every second digit. We need to double the relevant digits. We need to treat doubled numbers as 2 separate digits when they're greater than 10. So that presents another problem as well. So how do we separate? If it was giving me 16 as it was, how do I separate it into a 1 and a 6? I need to know when the end is of the number that has been reached, and I need to be able to read each digit separately. So how do I reduce this down and then to check if the sum is divisible by 10? So valid if it is and invalid if it's not. So let's reduce it even further. Knowing which digits to multiply by 2, I need to have every second character doubled, otherwise it's just a normal character that's added to the sum. What else do I need to know? Treating doubled numbers as 2 separate digits when they're greater than 10. So how do I separate a 2-digit number to add the digits together? Does anyone know how I would separate? So for example, 12 would be 1 plus 2. How would I do that mathematically, or in C even? What would I use? What would give me potential to see this? So how do I separate it out into its place values? Yeah, so you're right, I could do it with an if statement. It wouldn't be, it might not be efficient. The most efficient way to do it is to just do 1 plus, because I'm never going to go above 19, okay, with my doubled number, because the highest number I can double is 9, and doubled 9 is 18. So the highest number I'm going to get to is 18, which means it's always going to be 1 plus whatever the modulus of 10 is, because that will give me the remainder of that number. So if I do modulus of 12, if I do 12 modulus 10, that will give me 2. So that will give me 1 plus 2. So 1 plus whatever the number is modulus 10. Okay, excellent. So that's going to solve that problem. Knowing when the end of the number has been reached. So if I'm using getChar to do it, will the end be reached when I've done an EOF, or will it be a new line? And reading each digit separately. Okay, so if I read each digit separately, I might use getChar to read a character at a time. That means what I'm going to be doing is I'm going to need to convert that char to an int in order to be able to do any maths on it. So I've got a whole bunch of moving situation going on. And then last of all, I need to check if the sum is divisible by 10, which, can be done easily with an if statement. So let's have a look at the code that would then, go along with this. Okay, so let's do this one. Okay, so normally I would copy all of those steps into my coding file and then work from them, because that makes it easier to know what I am doing. So I'm going to do something like that now. Okay, so the steps were some of the different things that I was doing. Reading a character at a time. I was going to double the digits. And it was every second. What else was I doing? Check if valid. And that was if divisible by 10. And what else was I doing? Okay, so this problem presents itself very nicely for something that is a great contender to be divided up into functions, because it's very nicely done when I can divide things up into steps, and then I can do a little function for each of those steps, and that means that I'm cutting down on what's happening in my main, and it also means that I can write out my main in a way that sort of makes sense in English first. So I'm going to do that because that's part of reducing the problem down into steps that I can, count. So what I want to do is I want to get characters, and then we're going to fix it each time with code. So I'm going to get the characters. I'm going to get the character. I need to convert that character to an int. Okay, and after that, I might be doubling it. And after that, I want to add the integers together. Then I want to check if it's divisible by 10. Okay, so first things first. I think let's do, what do you think is the easiest function to do? I think the easiest function is to double something. What do you reckon? Let's do that. Let's do a function to double. So I want to double the integer. Let's call it double integer. And I guess I'll give it what integer to double? So I'm going to give it something. Okay, let's say I'm going to give it something called digit. Okay, so my function of double digit. Okay, so I'm going to double it. So I'll have a variable int double digit, and that's the one that I'm going to return out. Okay, so the first thing I'm doing is I'm going to double that digit. So it's going to be equal to that digit times 2. Now the easiest thing to do is if I send it already a 1, a 1, not a double integer digit, but just one digit. So I can check if it's greater, after I've doubled it, I want to check if it's greater than 10. So I'm going to use an if statement to check if my doubled digit is greater than 10. And if it is, then I'm going to straight away add, so if it's greater than or equal to 10, I'm going to add up the single digits of it. And we've talked about how to do it. We said that we can do it with our modulus 10. So that means that my new double digit would be equal to 1 plus whatever that double digit is with modulus 10. And that will give me the broken down number, like we discussed in the slides earlier. So that means that we've now got a lovely way to return a digit, and we also have a way to double things. So that means we've done this part now. So we've done may need to double the digit. We've done it. So what we need to do, I think something that's easy to do as well, is convert a character to an integer. It's something that you guys have done as well. So obviously I would need to what would I need to do first? I'd need to, before I give it a digit, I need to convert it first. How would I do that? How could I convert a character to an int? You can either do it manually or you can use a function that's available to you. How would you do it? Any thoughts how you guys would do it? Any thoughts, ideas? Yeah, so you can just use your a to I function, and that means you don't even need to do your own function. You can just use a to I, something that's available to you already. And then something easily that you can do as well is to check if something is divisible by 10. So you would send it that digit, you would send it the sum actually, wouldn't you? So that means you also need something called sum. And this is another way to kind of keep track of what variables you need. So I'd need something called digit, and I'd need something called sum, where I'm adding up all of the different possibilities that I have, all the different digits. Okay, so if we check divisibility by 10, I don't really need to return anything, do I? Okay, so if my sum is divisible by 10, then it's valid. Otherwise, it's invalid. Okay, so there's a lot happening already. So really all that I have left to do is just take in some characters now. Okay, you guys have done taking in characters, so how could I do that? And then do a little bit more, because I only need to double every second digit. So I also need to keep count how many things I've taken in. Okay, so what do you reckon? What will we do now? We're going to keep reading in things until and you guys have learned, I guess you've learned the char situation. So if I do, yep, so put get char in a while loop. Yep, perfect. Okay, so whilst, and I think there's a few ways you've learned how to do it. So you've learned how to do, let's say something like, so two possibilities, either, and the question didn't specify, it didn't have the constraint, it didn't tell us to read until EOF or new line. So I guess it's up to us what we want to do. So you can either do it like that, or you can put it inside the while loop. So whilst the character is not equal to, let's just go, I'll go till new line. but you can go until end of file as well. So whilst it's not equal to that, I'm going to take my digit and I'm going to convert that character. You could store values in an array. You absolutely could, but you don't have to really. You can just process them without. And it depends, when you decide on whether or not you use an array, you can see if it makes your solution more efficient. So I can keep track of my count as well to keep track of when I get to every second digit, and then just add them as I go in. So if I keep track of the count, I can then see if my count is equal to like every second number. So if it's an even number, then I will double it. So if my count is an even number, I will double it. If it's not, then I'm just going to add it to my sum. So my sum is just going to be sum plus the digit. And then I guess I'll get the next character out. Okay, so it's still a bit messy, but you would go back to it. No, I'm off in the, nope. I'm still in the while loop. Okay, so then at the end, I will check the divisibility to make sure it's valid or invalid, and then I could finish up there. Okay, so then if you were to run it, I forgot to do prototypes for all of them. That's my biggest, prototypes and semicolons. Looking for a semicolon in like 2,000 lines of code is always very painful. And where did I forget one? There we go. And I forgot to use oh yeah, line 58, was that the semicolon? Okay, and then now I've used A to I without using the right library. Oh my goodness, what have I done now? All right, without using A to I, I'm just going to do the very basic way of doing it, okay, just to start with. And then you can refactor it. Okay, so let's say we've got, I shouldn't have entered that number, because now we'll have to calculate it. What was the number that I had before? That we figured out was not valid. The number was 176, okay, 176,248. And it's invalid because it's not divisible by 10. All right, we're going to finish there for today. I kind of went a little bit off tangents. I'm sorry. I got a bit overexcited on the code. and then went a bit quiet. But thank you so much for tuning in. I really appreciate it. And I hope that you have found some of this to be useful. But always remember, when you're solving a problem, always break it down into, much smaller components and get down to the stage where there is something that you can do, and then work from that, and then build it up from that as well to gain some confidence. All right, thanks so much. I hope you have a good rest of the break, and I'll see you guys around, hopefully, when we're back in